Good morning or good afternoon, everybody. I know we have people coming in from multiple time zones. So it's morning here in Houston, and I know it's afternoon in the UK. I want to introduce Dr. Yuri Zhuk, and he will be our presenter today. And also here as a panelist, we have Mark Anania, who's with Hardide Coatings here in the US. So appreciate everybody coming on board. We're starting these profiles in technology. We expect this to become a weekly event. So Yuri, you are our guinea pig. You're the first one to come in and do these things. So without further ado, I will let you go ahead and get started.
Thank you, and good morning, everybody. So the topic to present today will focus on our Hardide coatings. These are nanostructured tungsten carbide coatings. Tungsten carbide is a widely used and highly respected industrial material, so we managed to produce it in a different form, which is actually working better in many applications. So first of all, to just show locations of where we are working. I'm based in the UK, near Oxford. So that's a headquarters of our company. And we also have production facilities in Martinsville, Virginia, from which we serve the North American market. But Hardide also has presence in Houston, and Mark Anania, who you will have contact details, and he is participating in this. He is based in Houston permanently and is an experienced oil and gas industry expert.
Thank you. Welcome, everybody.
So to start with, what is Hardide coating? It's a coating produced by a process known as chemical vapor deposition. So essentially, we are using a vacuum reactor. One of them is shown on the photo here. And we have a mixture of reactive gases flowing through the reactor, and every hot metal surface in contact with the gas media has the coating crystallized atom by atom. So what that allows, it enables us coating internal surfaces, external surfaces, spherical parts, complex shapes, all over non-line of sight areas. So that's probably number one capability or competitive advantage of our technology compared to other hard coatings. We use a low temperature CVD at 500 centigrade. Typically, we coat parts about 2 foot long, but we recently installed a larger reactor, which allows us to coat up to 4 foot long components. Typical thickness of the coating is about 50 microns, so 2 thou, and hardness on the level of about 73 Rockwell C. So it's about 1300, 1400 Vickers. So it's pretty hard. The main reason why it's used by the customers is wave resistance. And just to give you an idea, it is about 250 times more wear resistant compared to steel. The coating can be used up to 400 centigrade. And it is a virtually pore-free coating, which can be a very good barrier against corrosion, against some aggressive chemicals such as acids, and it's also quite effective barrier against H2S. So sour oil, sour gas can be very good areas for the use of our coating. As I mentioned, the coating is non-line of sight, so we can coat internal surfaces, external surfaces, complex shape parts, and we can coat a variety of steel components, stainless steel, tool steel, carbon steel, nickel-based alloys, copper-based alloys, so various metals. We coat metals mainly. So what you see on this slide is a cross-section of a 50 micron thick coating. You can see that it essentially follows the substrate. It's a conformal coating. It will repeat the profile or the features of the substrate. I wouldn't spend much time on this slide. You'll have a copy of it, but it presents different types of our coatings. So we can make coating harder, or we can make it softer and more ductile, depending on what the application requires. And again, I wouldn't spend time on this slide. It lists various materials that we coat. The majority of it is either stainless steel or tool and carbon steel, but also nickel-based alloys, copper-based alloys, and some other materials like cast iron, graphite. Just a few photos to illustrate that ability to coat complex shapes. Pump cylinders we coat on the inside. Pelletizing dies have hundreds of holes, so we coat both inside these holes on both faces of the die. Ball valves, extrusion screws, they all can be coated completely on whole external surfaces, working surfaces. Just to show a bit more details about that, illustrating that ability to coat uniformly is, for one of the customers, we coated balls for ball bearings, and they had to be coated all over. So what you see on the right-hand side is a electron microscopy image of a cross section, and the coating is a white layer here. You can see it's very uniform. Another application illustrating that ability to coat tricky shapes is coating mesh for screens, for filters. So what you see on the right-hand side is a cross section of mesh. Wires look like round or oval objects, and the coating is a white skin surrounding each individual wire. So this is what we can call a non-line of sight complex shapes. The coating has very good anti-galling properties. So when tested dry, hardide coated component against hardide coated component maintain a friction coefficient at 11.2, 0.2, which is about 1/5 of a typical stainless steel against stainless steel. And the samples didn't go even under higher loads of represent about 800 megapascals contact pressure. The coating that we produce is pore-free. So this illustrates that measurement method of porosity. And because of very, very low porosity, it can be a very good barrier against corrosion. So what is shown on this slide is 3 different coatings, HUF on the left, hard chrome at the center, and hardite on the right after salt spray corrosion testing. So you can see that the hardite coating did not show any signs of corrosion after 480 hours, and further testing up to 2000 hours still did not show corrosion. So it's a very dense, pore-free, good barrier against corrosion. More than that, it can protect against more aggressive media. So in this NACE test, it was tested in a mixture of salt, acetic acid, and H2S. So 2 samples shown here. The top one is uncoated control, and the bottom one is same substrate with hardite coating, both after 30-day test. You can see the difference. The uncoated control was actually broken into 2 pieces. That's a magnified view. The coating is used by practically all major oil service companies. And it's used in a variety of applications on directional drilling tools, on tools used in the fracking, on pumps, including electrical submersible pumps and also topside pumps, valves, turbo drilling tools, completion equipment. So there's a huge variety of components that we coat. And mainly the coating protects against wear, erosion, corrosion, galling. It can survive some shock loads. So the effect of use of the coating is that tools can last longer, that reduces downtime, reduces maintenance requirements, and also enables our customers to design better tools, better products. This is quite an interesting slide showing 2 types of sand screens that we coat. And the slides on the photos on the left show the mesh sands screens. You can see that in the cross section of the coated mesh, the coating surrounds each wire. On the right, that's a wire wrap type sand screen. And again, the coating is a white layer surrounding that profile wire. And by this, the coating protects the wires and the sand screens against erosion and also against acid attack. We also coat TSP diamonds, which are used in hard facing. The coating enables brazing that TSP diamond with much stronger retention because the coating has chemical bond to diamond. This testing of the TSP diamond shown that they can outperform tungsten carbide hard facing by a factor of 181 in wear resistance. Another interesting property is the coating is seal friendly. So in one application, the customer tested oil drilling wash pipe. And what we saw after some usage that the coating actually got more polished where it was in contact with the packing, with the seals. And as a result, the seals did not wear. So the seals and the wash tube lasted longer, did not leak, did not require replacement, and allowed continued operation for longer. And at the same time, the coating protected the wash pipe against corrosion. There's a concluding slide. So just to repeat, the coating that we developed and produced is a non-line of sight. So we can coat components which are very difficult or impossible to coat by thermal spray coatings or electroplating, including internal surfaces, external surfaces, complex shapes. It combines several protective properties in one coating. It protects against wear, against erosion, against corrosion, against galling. It also shown very good toughness, meaning that when used on oil drilling tools, it would survive some shock loads, deformations, impacts without failure. It also seal friendly, meaning that a seal component, seal contact can last longer, does not require as much maintenance. It's already used on a variety of critical parts in oil industry, but also we are very proud to say that our coating was approved by Airbus. So we are coating flying components for some critical components of Airbus aircraft now. And our coating enables companies which are manufacturing high value products, engineered products, to make their product even more competitive because their products with our coating can be differentiated and in terms of lasting longer, requiring less maintenance and performing better, reducing the life cycle costs. This slide, you'll have a copy of it that gives contact details of my colleague and friend, Mark Hanania, a colleague based in Houston, who would be very happy to discuss with you any application details. So we have to read this disclaimer, but probably after this discussion. So that concludes the presentation, and I would be very happy to answer any questions, please.
All right, if anybody has any questions, you can actually put them in the chat, or if you want to, you can raise your hand. You'll see the control on the lower part of your screen, and I can unmute you or give you the opportunity to talk. So does anybody have any questions? All right, let's see. And anonymous. Can the coating be applied to the outside pipe casing or tubing at full length?
Thank you. That's a good question. Our coating is a vacuum process technology. So the component to be coated has to fit completely within the chamber that we use for producing the coating. The largest chamber that we currently have is has a working volume 1.5 meter high. So that limits the size of the components.
Mohammed Uwe says, what standards do they use for surface preparation?
I'm not sure I fully understand.
I can take that one.
Yeah, please. Mm-hmm.
So there's no requirement for blasting the surface, for example, in preparation. All we ask our customers is that it comes to us clean and in the surface condition or surface finish that you would like to have it received back in. Because as mentioned before, Hardide will mimic the surface of the part as it gets, as the deposition occurs. So that's all we need, is just a good surface finish that you want the part back in. And once we do our coating and do our in-house polishing, that's how you will receive it back. So there is no surface prep per se.
And then there's a follow-up question, Mark, that you briefly alluded to. Is Mohammed also asked, is there any post-processing needed to meet the dimensions? And if so,
Yeah,
you'd mention some polishing, for example.
that's correct. In some applications, the surface finish, a specific surface finish is required. So the post-coating finishing operation is mainly to achieve a specified finish rather than dimensions, because the coating is 50 microns thickness typically. For many applications, that dimensions can be precisely maintained, sufficiently precisely maintained with the coating, so no post-coating operations are required. But there might be some precision components which do require post-coating machining, and this is possible. So the coating can be ground, can be honed on the inside, and polishing as well is possible.
I suppose depending on the application, then you could, if you had very, very precise, of course, you know, most tolerances aren't within the micron stage, but you could make something 50 microns under spec and then apply the coating, and then you would be dimensionally accurate as to what you wanted to do then.
Exactly, yes.
And Mohammed also has oh wait, sorry, it's Hank Vandenberg. Is the nickel layer always needed as an interlayer?
Nickel is used as an adhesive sublayer, so it's like essentially a glue for our coating, providing maximum performance adhesion. It's not always required. For example, components made out of nickel, components made out of copper, they can be coated straight without any sublayer required. But we produce that nickel sublayer in-house, so that's a process we refined and practiced many, many times.
Okay. Mohammed has another question. Do you need to do a holiday test? Does this apply? Not quite sure what that is. A holiday test?
Yeah, holiday testing is to see if there's any defects afterwards. Typically not. What we do initially is we will verify the dimensions of the part based on the drawing. Then we will check the thickness of coating that we apply to make sure that we hit the target and we are within spec. But it's very easy for us to identify if the coating didn't work out. And if that is the case, we can strip and recoat. So there are methods for us to inspect and to verify the effectiveness of the coating, and also hardness as well.
We have a follow-up question by Hank Vandenberg. Is the nickel layers made by Carbide, or must the customer provide it? And I think you answered that in your comments, Yuri, that it is provided by Hardide.
Yes, correct. It's made by Carbide, yes.
Okay, good. What do you, Mark, we've had some discussions around this, if you wouldn't mind maybe elaborating for a few moments. Where do you see the potential applications here in the U.S. market, particularly in oil and gas?
Sure. So we've been helping customers in the drilling segment in their downhole drilling tools for various parts that see excessive wear. So we're helping them to extend the life of those critical components. Same thing with frac tools, pumps. There's a lot of different applications for customers that we do. So anywhere, I would say, if you're using HVOF or other thermal sprays or other treatments, and they're not quite giving you the performance that you're looking for, or you want to extend, we can typically outperform those by several factors. And so what I ask customers is to try us out and to at least have us look at the application and see if it's a good fit.
And I guess this has been touched on a couple of times, but a little bit of a restriction is really the size of the component as to how what size it can fit into the chamber itself, right? And I think I heard you say about 4 feet or maybe 1.5 meters or so.
Yeah, correct. The 1.5 meters, that's the height of the chamber. Because the coating is produced from the gas media, so we have to allow some space for the gas circulation flow around the components. So typically 4 feet long components. That's the maximum we can do currently.
Okay, good, good. Hank Vandenberg has a follow-up. Is it used on tools for machining aluminum?
We have never really tried that application, but the coating that we produce, it's mainly chemically, it's tungsten carbide, tungsten carbide. And tungsten carbide is very good for machining aluminum because it does not form intermetallic compounds, unlike iron-based tools. So that's something we can try.
Okay. Good. Does anybody have any further questions? All right, great. Well, with that, we'll wrap it up. Thanks both to Mark and Yuri. We really appreciate you having come on. Hank has said thanks a lot. Yeah, so very interesting. This recording will be available on our IEDD YouTube channel. Typically, we'll post in about a half an hour. So we'll get this out. We'll let people know it's available, and so people can go back and look and review this if you like. So thanks everybody for participating, and we hope to see you again soon.
Thank you very much and have a good day.
Thanks, Jim.
Bye-bye.
Bye.